Good morning, all of you. Today we are going to start a new chapter, that is dual nature of radiation and matter. So in this chapter we are going to study how radiation, that means light, has dual nature and matter has dual nature. In the previous chapters, we have studied that some phenomena of light is there which can only be explained by the wave nature of the light. That means, suppose I will say interference, diffraction, some phenomena are there which can only be explained by wave nature of the light. And so there are certain other phenomena which can only be explained if we consider light as a particle. We will study this in this chapter. So I can say light has both wave nature as well as particle nature. Like a light, matter has also wave nature as well as particle nature. So we'll study how we have proved where radiation or light has both nature, and we'll also study the theory and practical experiment that matter also have dual nature. In this chapter, we are going to study about photoelectric effect. What is photoelectric effect? We will study in this chapter. Then Einstein's explanation for photoelectric effect, and we will study de Broglie hypothesis and wave nature of the matter. Also, we will study about how practically we have examined really examined that by Division and Germer experiment. We will study that matter also have wave nature. We will study lastly that electron microscope. We will study about electron microscope in this chapter. In today's class, we are going to study these things. First, we will study what is free electrons. Next, we will study what is work function. Next, we will study what is emission of electron. In emission of electron, there are three categories: thermoionic emission of electron, field emission, and photoelectric emission. We will study one by one. First, let us start from free electrons. So first, what is free electrons? We will study free electrons. So when I am saying free electrons, the first thing that comes to my mind is metal. We know from class 8 that metals have free electrons. So what is free actually? How much the electrons are free? What is the meaning of free electrons? Right? Look, here it is my metal, and here are some atoms. Atoms are, this is my nucleus and it is my electrons revolving around the nucleus. Sorry, these are the electrons revolving around the nucleus. I am zooming one atom here. This is my nucleus and electrons are moving around the nucleus. Suppose this is my valence shell. This is my valence shell, electrons are there. We know that between this electron and the nucleus, this valence shell electron and nucleus, the force of attraction is weak, right? So there is some weak force is there. So due to this weak force, the electrons get free from the atoms easily. They can easily move out from the atoms. When they get out from the atoms, this electron is now free. So this electron is called your free electron. Free electron. So what is free electron? Free electron means the electron which are free from this atom is called your free electron. Okay. So they are free from the atom. Are they really free to move out from the metal? Answer is no. They are free from the atom, but they are not free to move out of this metal surface. Okay. They can only free from the atom and they can only move inside this metal. They cannot move out from the metal. Why? Question is why? Because they are free, they can move, right? Then why cannot move from the metal surface? Look, when this electron is free from this atom, now this atom will become positively charged, and this is my negative. This positive charge, this is my negative charge. There will be some attraction between this positive and negative. We know Coulomb's law from the first chapter. there will be Coulombic attraction between this positive metal ion and this negative electron. So this positive metal ion will try to pull this electron towards itself. They will not allow this electron to move out from the metal surface. Due to this present atoms, electrons cannot move out from the metal surfaces. So to move out this to move these electrons out from the metal surface, to move this electron out from the metal surface, we have to do certain extra work on it. That means, suppose I have to flow certain current in this conductor. When I have to flow the current in this conductor, that means I have to apply the potential. I have to do certain work, right? करंट कब फ्लो होता है? जब इलेक्ट्रॉन्स मूव करते हैं, राइट? इलेक्ट्रॉन फ्री होकर मूव करते हैं तभी तो करंट फ्लो होगा ना. सो करंट फ्लो करने के लिए हमें क्या करना पड़ेगा? एक बैटरी लगाना पड़ेगा. बैटरी क्या करता है? वर्क करता है. बैटरी पुश करता है. ओके, दैट मीन्स वी हैव टू डू सर्टेन एक्स्ट्रा वर्क टू मूव दिस इलेक्ट्रॉन्स आउट ऑफ द मेटल सरफेस. दैट वर्क इज कॉल्ड योर वर्क फंक्शन. The work function. So what do you mean by work function? Work function means the amount of work we have to do to move this electron out of the metal surface. Out of the metal surface. Let's write it. Work function means the amount of work done to move electron, or I can say free electron. Move free electron out of the metal surface. Out of the metal surface. This is called my work function. That means how much work I have to do to move this free electron out of the metal surface, right? That is called a work function. This is symbolized by phi naught. Phi naught is symbol for the work function. Work function. Okay, so phi naught is work function is symbolized by phi naught. Okay, work function depends on which factors? Is the work function is same for all the metals, all the materials? Answer is no. Work function is not same for all the metals. It is different. Different metals have different work function. For example, I can say there is a wood. There is one piece of iron and there is one piece of copper. So I'll apply certain voltage here. I have to do certain work means I have to apply certain voltage here. In every case I have to apply certain voltage. In which case current flow will be easier and faster? Answer is copper, because its work function is less. I have to do less work to move electron out from the metal surface. Here it is easier for me to move electrons out of this metal surface, and in this case it is very tough because its work function is more. I have to do more and more work here to move this electron free from the metal from this surface, right? So I can say every metal have different work function. Every material has different work function. So I can say work function depends on nature of material. It depends. First thing I can say depends firstly nature of material. How is the nature? Okay, so first thing, work function depends on nature of material. Second thing, temperature. More the temperature, electron will be easily freed. टेम्परेचर हम जितना बढ़ाएंगे इलेक्ट्रॉन उतना इजीली मूव कर जाएंगे आटम से, सॉरी मेटल से, राइट? सो वर्क फंक्शन टेम्परेचर अगर हाई होगा तो मुझे कम काम करना पड़ेगा, वर्क फंक्शन विल बी लेस। अगर टेम्परेचर कम है तो मुझे ज़्यादा काम करना पड़ेगा। सो वर्क फंक्शन डिपेंड्स ऑन नेचर ऑफ द मटेरियल एंड टेम्परेचर। सो सपोज एक मीटर है, I have seen that if I have to apply 10 joule of work, then after applying 10 joule, this electron is now free from this metal surface. Now this 12 joule, I have to apply 12 joule on this metal surface, so that this electron will get free. That means 12 joule is my work function. 12 joule is my work function. Below 12 joule, suppose I will apply 11 joule. Okay, here the electron will not be freed. Next thing we will study about what is emission of electron. Emission of electron. What is emission of electron? Emission of electron. As the name says, emission. Electrons are emitting. Electrons are releasing from this metal surface. Right? The emission of electron means we have to emit this electron from this metal surface by some process, by some methods. Okay, so there are three methods to emit electron from the metal surface. The first, let's study about what is thermo-ionic emission. What is thermo-ionic emission? In thermo-ionic emission means, here I have to have thermo means heat, right? I have to emit the electron due to the effect of heat. Due to the effect of heat, I have to emit the electron. That means, suppose there is a filament tube, right? Your bulb, you have tube, right? That type of thing is there. When I will provide high potential, high tension or high potential here, due to this high tension, high potential, heat is generated here. Due to this heavy heat, electrons in this filament are released, are free. So these electrons are free from the metal surface inside this filament due to this heavy heat. Due to this high tension, there is a development of high heat. Due to this high heat, electrons are free from this surface, metal surface. This process of emission of electron is called your thermo-ionic emission. Okay, this type of process of emission of electron is called your thermo-ionic emission. Second thing is your field emission. Field emission. Field means electric field. That means, suppose there is a field, positive charge here and negative charge here. Inside this field, I have placed a metal surface, right? I have placed a metal surface here, positive, negative, right? When I place a metal surface here and I am providing high tension here, it is also here the field is here the potential is very high, right? So due to this high potential, what will happen? In the electrons inside this metals will move near the positive plate, will try to move near the positive plate, right? This positive plate will try to pull these electrons towards itself due to this Coulombic force, right? So electron will try to move towards the positive plate, so they will be free from the metal surface and they will move out from this metal surface due to this effect of positive ions, due to this effect of electric field, right? So this process of emission of electron due to this presence of electric field is called your field emission. It's called your field emission. Last thing we'll study about your photoelectric emission. Photoelectric emission. Here photo means light. Suppose it is a metal surface and I am throwing a light here. Due to this light, electron get free from the metal surface. When I am saying light, I am not saying irregular light, visible light. There is certain range of frequency. There is certain particular frequency of light under which electrons get free from this metal surface. Okay, this when we will apply certain range of frequency, high frequency light, I can say high frequency light. When I apply high frequency light, this high frequency light will force these electrons to move out of the metal surface. So this electron are free from this metal surface due to this application of light, due to this effect of light. Due to this light, the electrons are free. So this process of emission of electron is called your photoelectric emission. So we have studied that what is thermionic emission, we have studied what is field emission, we have studied about photoelectric emission. Okay, thank you for today's class. We'll study in detail in the photoelectric emission in next class. Thank you.